All right, I am going to move right into adding delineations. Delineations are important. Delineations are kind of the million-dollar question because getting real good delineations to all of the trash capture BMPs out there in the county is a huge task. And to do it really right, we'd have to build a system that knows what you know, but also knows what you don't know. In other words, all the private drainage on sites, inlets that you don't have mapped, et cetera. We know we're working with an imperfect data set of where your knowledge of where inlets are and where they aren't. We also know that we're working with an imperfect data set about the digital elevation model. It's pretty good. It's an excellent resource for the county to have a digital elevation water model county-wide, but it still doesn't resolve all the tiny little micro topography in the county. So delineations are tough. And what we've tried to do with this first version is to spend some money identifying the most flexible and sort of lowest hanging fruit in terms of supporting folks with developing delineations for BMPs, or using delineations that you may already have. So trying to find various different flexible options for doing this. But to be perfectly clear, you don't get any credit for having a BMP at a point. You only get credit for that BMP when you've been able to identify the area that drains to it and demonstrate that that area is being captured by that BMP. So delineations is critical. So I'm going to talk through a few different options that we support for delineations right now. The easy one, but of course challenging to know if you're doing it right, is to just draw it on the map, either in the field or from your desktop, drop points, draw a polygon associated with the BMP. We've also worked with OC Survey closely to develop a geoprocessing routine that can use that digital elevation model, and it can traverse the topography and delineate everything that it thinks drains to an inlet based on the presence of other inlets in the watershed that you've mapped, and it respects the topography of the watershed. So this is a really powerful option. It needs to be enabled for your jurisdiction, and I'll provide some thoughts on what that means for you. But once you've got it enabled, it can be a really valuable tool to get a lot of delineations quickly and support you with populating new ones as they come up. Tracing regional subbasins. So many of you are familiar with what was originally called the WIMP catchments. We call them regional subbasin catchments. One and the same, they're these 40-acre nominal catchments where they have a downstream node routing. So if you point at one, you'll be able to figure out all the catchments that are upstream of it quickly. So being able to trace that network of subbasins is something we support in the tool. And this is most valuable when you have a regional scale BMP. It's clearly not going to work for you for an individual catch basin screen or even a CDS unit that may be at a smaller scale because it's just too coarse of a network. But for larger BMPs, it's a great resource to quickly delineate a large area, and then we could refine from there. And then finally, an upload from GIS. Right now, we're not exposing this to normal users, but it's a tool that a widget we can use inside the tool to upload your GIS, and so that can be another option. So with that, I'm going to go into the first demo section of this, where I'm going to talk through a few different options for adding delineations. And I'm going to go ahead and use the point area as my first example. And I'm doing this in a test version of the tool, so anything I'm doing isn't going to mess with your inventory, Lisa. Don't worry about that. So the first option that I just want to demo is, we're going to get to the delineation map here by go ahead and clicking on the delineation map up here on the ribbon. You will see all your BMPs. You'll also be able to turn on and off the stormwater network. So the stormwater network is a network that's maintained by OC Survey. They've compiled data from various jurisdictions. It's a pretty good data set. You may have a better data set that you'd like us to use instead, and we can work with OC Survey to incorporate that. This is a pretty good reference in a lot of areas. And so you'll see, and I click on this BMP, it doesn't have a delineation. We click on edit, and this gives us the options to start delineating the drainage area. So we have really two options here. Does it receive just local surface flow, or does it receive both surface and pipe flow? So local surface flow implies that we're going to delineate up to the next upstream inlet, etc., but we're not going to trace the pipe network. We're not going to trace the regional WIMP network up into the watershed. And so we'll just start with looking at the options that are available if you select local surface flow only. We can either delineate automatically from the DEM, or we can just draw the catchment area. So I'm going to start with the simplest one and go ahead and do this. And so as I look at this now, I get a little cursor. I can just start dropping points on this and saying, delineates up to this inlet, this half of the road, and we can go ahead and close that and then save. And we've recorded a new provisional delineation. So if I ask my technician to do this, I might see a bunch of these appear. Hopefully they take a little more time than I just did to think about exactly where things drain based on other resources they may have available. After you look at it, you can go ahead and change this to a verified delineation, and it's going to start being used to actually perform the calculations. So we've now added a delineation to the system, and when I click on that, I can see the BMP it's associated with. If I go to this BMP detail page now, I am going to see that delineation appear now in the BMP detail page, and I'll have a chance to, it becomes part of my inventory, so to speak. All right, so my next option I'm going to demo is to go ahead and use the automatic DEM. And so Lisa has gone through the process of reviewing her inventory. She said all the gray boxes here that are in the county stormwater network data set represent my inlets pretty well. There's not a whole bunch of inlets that I don't have in here. These aren't out of date. So she told us this is a good inlet data set. Go ahead and process the DEM, including these inlets. And so we did that, or actually OC Survey did that. They processed the DEM, which effectively means that they're burning little depressions in every time there's a gray box, creating a hole in the DEM, so to speak. And then they're doing the flow direction, flow accumulation map. So anybody familiar with ArcHydro, that's the sort of thing that's going on. And it's creating the kind of system, the geoprocessing service, where when we tell them, hey, there's a BMP here, can you give us the delineation back to that BMP? We send that command, and I should have gotten this started because it does take about 20 seconds to run. And it's going to send a command over to the OC Survey geoprocessing server, and that's going to be traversing this DEM. It's going to send this back to us as a polygon that we can then work with. I will say that doing this one by one for 1,000 inlets is not a good idea at all. So the other option we provide, and I'll show you what it looks like in, say, Tustin, where we've gotten these back. We have them run it for all the known BMPs, and so they're giving us back the delineations as polygons, and we can get them uploaded. So what you start with is pre-populated polygons based on this service, as opposed to having to go through and do it one by one. So first it comes back, it's a little bit thick. You really want to edit this. Maybe you know that it doesn't take all that area there. There's a grade break there that I know of that this tool doesn't know of. So we can edit vertices, and we can do that by thinning first, because that's too many vertices to edit. So we have a thinning algorithm, so you can sort of start to thin the vertices. Go in here quickly, just click on solid vertices to delete them, or click on hollow vertices to add new ones until it looks like it's about right for this, and then go ahead and click save, and that becomes a stored delineation as well. And you can see this respects the topography, it respects the presence of other inlets in the system. The water that's draining into this inlet and this BMP is not flowing past and down to this BMP. So it's doing a decent job as from our inspection of delineating. Now, where you have a private site, shopping mall that has a bunch of inlets on site, you don't have those in the inventory, it's not going to respect that. And you might see an over delineation, more area draining into a BMP in the right of way than what really happens because those private inlets are not represented. And so that's a case where going back and doing some manual correction to carve out those parcels will be necessary in terms of getting a better set of delineations to BMPs. All right, I'm going to go ahead and show you what this looks like when we start to use the regional options, the regional trace. So this is the Salt Creek Ozone Treatment Plant in Dana Point, and we'd expect this to have a really large drainage area. And so let's see if we get that. So it's going to receive both piped and surface flow. This is now a regional centralized option. Let's trace the network catchments and see what it returns. So indeed, we are getting the Salt Creek watershed effectively being delineated in this case. And so, you know, as good as the WIMP regional subbasin delineations are, this delineation is going to respect those. So say we're looking at this and now Lisa says, well, I know, yeah, that's where the delineation boundaries are, but in reality, everything this side of the PCH doesn't. And so we do have the option to start editing vertices. We could, you know, spend a little time editing the vertices to bring this over here. We could thin these a little bit if it made sense, and make it a little easier for us to edit the vertices and create a little bit truer representation of the drainage area to that. So you may find that because this backbone of regional subbasins is somewhat coarse, that near the BMP especially, you may need to edit that delineation to make it represent the true drainage area there. Go ahead and cancel this and save. And so now we have a delineation to that setup. And I think, you know, I think that's about it for delineation services. This is just the first overview. What exactly, the method exactly that you use to do this will probably depend on the data you have available and what you want your workflows to be. So if you're ready to get started on this, you think this would be useful, let us know, and we can kind of talk through what data you have and what may be the best approach through this for you.